This video is over angle-arc relationships. So before we get started, we actually have to go through. Our first new vocabulary word is an inscribed angle. So an inscribed angle, the angle lies on the center. It lies on the outside of the angle. So say this was angle MOP. The inscribed angle would be MOP. For a central angle has to come from the very center of the angle. And the legs of this angle would be the radii of the circle. So say this was angle EFG. So this central angle is EFG. We also need to talk about arcs. So we have two kinds of arcs. We have a major arc and a minor arc. So first let's talk about the minor arcs. So we have MP right here. So the arcs intercept the angles on the circle. So this right here is a minor arc. And this is arc MP, written like this. EG is also a minor arc, written like this. So the difference between major arcs and minor arcs. So for a minor arc, it measures less than 180 degrees. And then you can probably guess that major arcs measure more or greater than 180 degrees. So we have major arcs. So this one would be major arc, MOP. And you see how major arcs have 3 letters? This one, for the other picture, I would have to add another letter to have a major arc. So I can add point R over here. And then I would be able to have a major arc. So this would be major arc ERG. So a few vocabulary while we're learning these new formulas on these next slides. So there are 4 equations that we're going to talk about that deal with the angles and the arc relationships. So angles and the center. So these are angles that pass through the center of the circle. So say I had angles that look like this. So these angles are vertical angles, so they're both congruent. So say this is angle X. And the arc is RS. So if I wanted to find the measure of the angle, X is going to be equal to the arc of RS because it's in the center. So I can actually do this backwards or forwards. So an example, if I knew the measure of arc RS was 30 degrees, find X. X would equal 30 because the arc and the X are equal to each other. I can also do this backwards. So, example, if x equals 70 degrees, find the measure of arc RS. Well, the measure of arc RS would equal 70 because these are equal to each other. For angles on the circle, so these are our inscribed angles. Say I had a measure of my angle X, and say that my arc here was Y. So X would equal half of Y, and Y equals 2 times X. So these are your two equations, and they're just, if you know the X, then what's Y? If you know what Y is, then that's what X is. So let's give an example. Say I'm given a circle with an inscribed angle. Use different letters. So, say I know the measure of angle MOP is equal to 52. I want to find the measure of the arc MP. So since MOP is my inscribed angle, MP would have to equal 2 times my inscribed angle. So MP would equal 104. So the measure of that arc is 104. For angles in the circle, but not in the center. So say that I have lines that meet like this. And I have arcs. This will be arc Y. And this will be arc Z. And our angle here is in the middle. So to find the measure of that angle, I would take the measure of my arcs. So X equals the measure of my arcs added together divided by 2. Okay, so let's do an example. I have my circle, and I know it looks beautiful. I'm going to name my arc. So I have arc AB and CD, and I have the point M in the middle here. It's not in the center, it's just we're inside the angle, inside the circle, sorry. So if the measure of arc AB is equal to 72 degrees, and the measure of arc CD is equal to 26 degrees, I want to find the measure of angle AMB. So the measure of AMB, which is like our X, is equal to adding those two arcs. So 72 plus 26, and then dividing by 2. 72 plus 26 is 98, and divided by 2. So the measure of angle AMB is equal to 49 degrees. And for our last formula are for angles outside the circle. So if I have two secant lines that form outside the circle, like this, and then I'll have arcs. Right here, I have one arc. It's going to be arc Y. And then I have this other arc, which is arc Z. And then I have my angle X. So X equals Y minus Z divided by 2. Now let's do an example. So if I have my circle and my secant lines, and I have arcs MP, and I have another arc EF. So say that the measure of arc MP was equal to 108, and the measure of arc EF was equal to 63. We want to find the measure of angle MSP. So this angle right here. So the measure of angle MSP would be equal to my bigger arc, 108, minus my smaller arc, 63, divided by 2. So on the top here, I'll have 45 once I subtract them, divided by 2. So the measure of angle MSP is going to be 22.5 degrees.